Welcome to Mitchell Maths. In this video we're going to have a look at angles in triangles and parallel lines. So it's mostly just finding the missing angles in these types of things. Right, so the triangle below is isosceles and we want to find the value of x. Now with an isosceles triangle, what that means is that the triangle has two sides which are equal, which is indicated by these bars. So that means we know that these two sides are equal. And what's special about an isosceles, the other thing that's special about an isosceles triangle is that two of the angles are also equal. So you've got the angle that's in between the two lines which are the same, but then the other two angles are the same. So this angle is going to be the same as this angle here, which makes it possible for us to work out the other angles in an isosceles triangle when we've only got one of the angles, which we wouldn't be able to do in a regular triangle or a triangle with different sides of different lengths. Right, so we'll do 180, take away 42, so we know that what these two angles will add up to. And that gives us 138. And because we know that these two angles are the same, I can divide by 2. And that will equal 69 degrees. So that's my missing angle x. Lines AB and CD are parallel. So we can see that these two lines are parallel. And one of the what we can see is actually there's something called alternate angles. Also sometimes called Z angles, which means this angle 38 degrees here is going to be the same as this angle here, which is also going to be 38 degrees. So that means that Y is 38 degrees. So if you're ever looking at parallel lines and you see sort of like this Z thing, then the two lines either side will be equal. And because X and Y both lie in a straight line, we know that angles in a straight line add up to 180. So to find angle X, what we can do is we can do 180, take away 38. And if we do 180, take away 38, that equals 142 degrees. So question 3 is find the value of x in the figure below. We've got one angle in the triangle and then we've got one angle outside the triangle. But we've got two straight lines passing through each other here and here. And when two lines pass through each other, the lines either side, opposite to each other, are equal. And that's called vertically opposite. So angles which are vertically opposite are equal. That means this angle at the other side of the line here is also going to be 58 degrees. And now that we've got another angle in the triangle, we can work out what angle x is, because we'll just do 180, take away 88 plus 58, and that equals 34 degrees. So that's angle x. In the next question it says find the value of angle x in the figure below. And we can see that we've got an isosceles triangle here, and as we said before, this angle will have an angle here, but then the other two angles will be the same. So because that's 72 degrees, we also know that this one will be 72 degrees. And we can use this angle here in order to work out the angle at the other side for this triangle, because they both lie in a straight line. So if we do 180, take away 72, that's going to equal 108. Therefore, we've got 108 degrees here. And then we know that angles in a triangle add up to 180. Therefore, we can do 180, take away 108 plus 40. And if we do that, we get 32 degrees. Angle X is 32 degrees. Now we're going to have a look at some which are a bit more tricky. In this one, it's we've got AB and CD are parallel lines. So we know that, and that are parallel. And we've got these two angles which both contain X. And what we can see from this is these two lines are parallel and they're connected by a straight line. And when two parallel lines are connected by a straight line, the angles here are going to be equal to 180 degrees, which will help us. We know that 5x minus 8 plus 3x plus 4 is going to equal 180. So if we add that up, that's going to be 8x minus 4 equals 180. Let's add 4 to both sides. That gets us 8x equals 184. To get x on its own, we need to divide by 8. So we're going to divide both sides by 8. And that gives us x equals 23. So that means the value of x is 23 degrees. Now we can work out what y is. So what we'll do is we've got the value of the angle here, which is 3x plus 4. That means it's 3 times 23 plus 4, which is 73. And because this angle and y lie in a straight line, we'll do 180, because we know that angles on a straight line add up to 180. Take away 73, and that equals 107 degrees, which is y. You could have also actually had a look at this, because again we've got alternate angles, z angles. So y would have actually been the same as 5x minus 8, so we could have worked it out that way as well. So for the first part of that question, we used allied angles to work out what x was. We made an equation using allied angles. And then for the second part, we could do angles on a straight line, or we could do z angles in order to work out the value of y. And the next question we're going to do, ABCD is a parallelogram, find the value of angle x. So this is sort of like a triangle / polygon question. Right, so we've got, we're trying to find angle x. Immediately I can see that we've got a triangle in the middle, so it's going to help if we work out this angle here. I'll need to do 180, take away 89 plus 51. So 89 plus 51 is 140. So 180 minus 140 is 40 degrees. Therefore, we know that this angle is 40 degrees. Now we know that, because we know that these two, this is a parallelogram, ABCD, we know that opposite angles in a parallelogram are equal. So that means that x plus 44 is going to be equal to 99. Oh, sorry, plus 40 is going to be equal to 99. Therefore, if I take off 40 from both sides, I get x equals 59 degrees. So that's my value of x. You could also use allied angles to work out if you the value of x if you wanted to, because you do know that AB and CD are parallel, and also AC and BD. So you could use that, but I think it's probably easier to do opposite angles are equal. Right, thank you for watching. I hope you found that helpful. If you liked the video, please hit the subscribe button to see more videos. And for practice questions, visit www.mitchellmathsandscience.com. The link is in the description.